Hi, Assalamualaikum and a very good morning. So now we're going to do tutorial discussion for chapter 1 and we're going to focus on the subtopic of 1.1 atoms and molecule. So we're going to do tutorial question 1, question 3, question 4 and question 7 respectively. So without any further ado, let us start. So for question 1b1, we need to write the isotope notation for each of the following species. So we have our silicon 28 and we are given the number of protons Z, the number of neutron and as well as the electron. And we need to write the isotopic notation here. And as you know that, in order to write the isotope notation, we need to have our chemical symbol X and then we have our nuclear number on this side and our subscript here gonna be the proton number, and the nuclear number is basically equal to the proton number adding up with the number of neutron. So for the notation of silicon, it's basically going to be Si, and then the proton number going to be 14, and then the nuclear number is basically proton plus neutron, which going to be 28. And because the proton number and the electron is the same, so it doesn't have any charge. So you're going to look something like this. For Cl, you will have 17 proton number and the nuclear number going to be 17 plus 20. So you're going to get 37. And as what you can see here, the proton is 17. The electron is 18. So it has one extra electron. So it's going to carry a negative charge. Okay, for sodium, we're going to have 11 proton. And then for the nuclear number, it's going to be 11 plus 12, which is 23. And as what you can see here, the proton number of sodium is 11, but the electron is 10. So the electron reduced by 1. So it has donate 1 electron. So it's going to be a positive charge. So it's going to be 23, 11, and 8 plus. So that's all for question 1b1. For question tutorial 3, the following is the mass spectrum of zirconium. Calculate the average mass of zirconium, so ZR. So in order to find the average atomic mass of zirconium, we're going to look into the mass spectrum here. So we are given the percentage intensity, or known as the percentage abundance, and then we're going to have our masses here, isotopic masses, so Mi here. So in order to find the average atomic masses, we're going to do the E key me over E key. So the percentage abundance will be multiplied by the mass, and we need to do that for every cases. Okay, so we're going to do 52 multiplied by 90, 9 times 91, 12 times 92, 14 times 93, times 13 plus 13 times 94. Okay, and then for the summation of the abundance is basically 52 plus 9 plus 12 plus 14 plus 13. So this one going to be below here. So once we do the maths, what we're going to get is 92.27 U, which U here refers to the unit. Okay, atomic mass unit, or simplified as unit. Okay, and since they are talking about average, we don't have to find the relative atomic mass, so we can stop until here. Okay, now for tutorial question 4. So for tutorial question 4, iron consists of 5.82% of 54 ferrum, 91.66% of 56 ferrum, 2.19 of 57 ferrum, and 0.33% of 58 ferrum. The isotopic masses of these 4 isotopes are given as here. So we need to follow the isotopic masses. Okay, so we have 5.82 with this value, which is 54. 54 ferrum will have 53.9396 units, so we need to follow this one. 56 will have this value, and 56 going to have this value, and 57 going to have this value. So we need to calculate the relative atomic masses of iron. So when we're talking about relative, it's not going to have any unit. So similarly as before, we need to find the average atomic mass of ferrum first. So we're still going to use E CHEMI divided by E Q. So the percentage here going to refers to the Q, and the isotopic mass here refers to M. So 58.82 going to be multiplied by 53.99396, okay, which is this one. And then 91.66 will be multiplied by 55.9394. 2.19 will be multiplied by 56.9354. And 0.33 will be multiplied by 57.9333. So be very careful because sometimes you misnumbered the digit here. Okay, so please double check. And then your percentage is percentage of abundance, which is Q, is basically 5.82 plus 91.66 plus 2.19 plus 0.33. So here supposed to have 100. Okay, so once we do the maths, we're going to get 55.85 AMU. Or you can say that it is unit because the given here is unit. Okay, and now we're going to get the relative atomic mass. So in order to get the relative atomic mass, we need to compare that with 1/12 of the carbon-12. Okay, so we have our mass of ferrum, which is 55.85 U, divided by 1/12 times 12 U, which is 12 carbon is equal to 12 U. And then this is going to cancel out, become 1, and unit the unit can be cancelled out. So at last we're going to get 55.85. So it doesn't carry any unit. Okay. Now for tutorial question 7, the isotopes of the argentum occurs naturally as 107 Ag and 109 Ag with their relative isotopic masses of 106.906. Okay, so this one is for 107 Ag and 108.868 respectively. So this one going to be 109 Ag. Okay, and if the average of atomic mass of argentum is 107.868, what will be the percentage abundance of these two isotopes? So we need to find the Q for the Q of 107 Ag, and we also need to find the Q of 109 Ag and percentage. So you know that the addition of this one and that one going to be 100%. So in order to do that, we can assume that the percentage abundance of the 107 argentum is going to be X. Meanwhile, the percentage abundance for the 109 argentum going to be 100 minus X. Okay, because when both of these add up together, it's going to be 100%. Okay, so the same thing as what I took in lecture. So it can be here, X here can be 10%, and hence 109 Ag can be 100 minus 10, which is 90. So when you add up together, it's going to be 100. Okay, so by having this kind of assumption, now we can use our formula of the relative, the average atomic mass, and we're going to use E CHEMI over E Q. So the average atomic mass of argentum is 107.868, and it does not have any unit. And we're going to do the multiplication of the Q, which is of the Q of 107 Ag, which is X multiplied by 106.906. So this one is correct. And 100 minus X will be multiplied by 108.868. So this one is correct. And X plus 100 minus X basically equal to 100. Okay, So we're going to expand these brackets here and we're going to get this value, and we're going to bring the term together, x and x. Meanwhile, for this one, we're going to bring it to the left hand side. So what we're going to get is negative 100 as well as negative 1.6, negative 1.962x, and then the negative and negative can be cancelled out, and then we settle the value. We find the value of x here, where we're going to get 50.964, or you can put it as 50.97. Okay, and you don't please do not leave your answer like this, because you need to make a conclusion, because they ask you what is the percentage abundance of these two isotopes. Therefore, you can say that the abundance of the 107 Ag is equal to x, where x here refers to 50.97%. And for the abundance of 109 Ag, it is equal to 100 minus 50.97. And we can get 49.03%. Okay, and this is how you answer the question fully and completely. So I think that's all for today's video. See you again some other time. Bye.